3, sorry. 3, which is the two-dimensional motion. Now, just here, I have an image for two things. The yellow here, it is the yellow ball. It is fired horizontally, which means it is sent like this with an initial velocity VI. Now the other one, okay, the pink one, it is dropped. Dropped means it is 0 velocity and it is free fall. Now if you look at the two motion, the vertical, I would say the vertical motion is going to be the same. For example, like they were here and then here and then here. You can see that if they are dropped from the same height, they are going to be arriving the ground at the same time, because the vertical motion is the one that is, making the time. And the second thing is that they are really having the same vertical velocity. Now, when we talk about the total velocity or the velocity of the two objects, no, it's not the same. I will say the total velocity is not the same. Whereas if I'm talking about the horizontal one, the vertical one is going to be the same. Okay. Now, but like the yellow, you can see that it is making a horizontal distance. Let me now start solving problems for you here. And the first one, it is about, as I said, 0 launch angle, or we call it horizontal projectile. Now, we have here a diver that is running. A diagram always is very helpful. Then I have a diver that is gonna dive horizontally. From the edge of a vertical cliff and reaches the water below 3 seconds later. Now, this is here my y. I usually use my initial y and my initial x to be 0. Now, they are asking about the first one, how high was the cliff? What I will do here is I will say, I will put my quantities all in kind of a box here. And I'm gonna list my quantities. My yi is 0. I need my final y. The initial velocity here, it is 1.6. The acceleration along the y, it is negative 9.8. And the time is 3 seconds. I said now here for the velocity we should have an x and y component, but for when it is horizontal we are going to find that the 0y is going, or the VIY, let's say, is going to be VI sine, and the angle that is really the velocity is making with the x-axis is 0, then it's going to be sine 0 is 0. And this is the reason why VIY is 0. There is another velocity which is, we call it VIX, and that one is VI cosine theta 0 and cosine 0, and cosine 0 has a cosine that is really 1. Okay, therefore I will say here, if I have a velocity which is 1.6 meters per second, cosine 0 is 1, then this is going to be the 1.6 meters per second. Then in this one here, I want to use not VI, I want to use my VY initial, and that is 0, because I am talking only here about the vertical motion. Now, let's start working with more stuff in here, which is, okay, which equation is going to be the best here to use, since I have all these parameters. And what I will do is I will start thinking of the equations that I have, and the 4 equations, remember that I listed them for you. Then you are going to look at these and find out which one is the best one to use. Usually I will say it's very easy for you to pick one and only one. Sometimes you are going to find that you can have more like one equation that is going to be fitting. That's okay, but I will say most of the time we're going to have it only just one equation that is going to be fit. Now, I will say here, I know that y final minus yi, which is delta y, equals VIYT plus 1/2 AYT squared. And remember, we said we use that to be 0, then y final is going to be also VIY is 0, and that is going to be the easy case when I will say that this is -8 meters per second square times t squared, and t is 3 seconds. Then you will be able to say, all right, this is 9.8 times 9, because you squared, don't forget to square, divided by 2, and that is going to be 44.1 meters with a negative. This is the displacement of the diver, and if you wish to find the height of the cliff, then is going to be 44 meters. You cannot use the equation without the negative, because you actually what you are measuring first the displacement of the diver, and the displacement of the diver is negative, and we will use that to measure the height of the cliff, which is going to be 44. Now, the second equation here, or like the second one, is asking about more things. For example, is how far from the base of the cliff did the diver hit the water? Okay, then here I want to find the x in meters final, and that is, I don't know, xi is 0, and my vx, which is the same as my v y, this is the same, my vx, it is the same as my vix. Vix, we said, is going to be the 1.6 meters per second times 1, which is the cosine 0, and this is gonna be 1.6 meters per second. Okay, there is here no square. Okay, that is no square here. And the time is again 3 seconds. Then, oh, the time, it is in seconds. Okay, the time, it is listed here in seconds, and this is 3. Then here I will say x final equals xi plus Vx times t, and x final is the 1.6 meters per second times 3 seconds, and that is gonna be 4.8 meters. Okay, then that diver is gonna end up with having a horizontal displacement that it is 4.8. This is another one about horizontal. Then this is, I will say, example 2, where we have a ball again that is thrown horizontally. Okay, this is VI, and the building is 45 meters, and it lands 24 meters from the base. Okay, now again, I will say my VIX is gonna be VI cosine theta, which is 0, and that is gonna be VI. And for VIY, it is VI sine 0, and sine 0 is 0, then this is 0. Now, usually, if you have the, the information from the Y, you can use it to calculate maybe time or other stuff. Then I will say, let's arrange our values in that chart. And I will say here what I have. VIY is 0. Y final is negative, because remember the ball is moving downward. A meters per second square, negative 9.8. Here I'm adding another digit because I have 3 sig fig. And finally, and don't mix x with y, okay? Then you're gonna solve for x by itself, for y by itself. Okay, what else I know? I'm looking for the time, because this is the only connection between the two motions. Then now what I can do is, again, y final minus y initial equals v0 yt plus 1/2 ayt squared. Again, this is 0, and this is 0 as well. Y final is going to be 1/2 ayt squared. Y final is negative 45 meters, and this is negative 9.8, and this is t squared. In order to calculate t squared, you will say, of course, the minus is gonna cancel from both. 45 times 2 divided by 9.8, and that is t squared, and then I will be able to calculate the square root of that, and my t is going to be 3.03 seconds. Of course, here I can use also the x equation, which is x final equals xi plus vx times t. X final is given as 24 meters. This one is 0, and I will say Vx is going to be the unknown times the time, which is 3.03 seconds, and then Vx is 24 divided by 3.03. Then Vx, it is 7.92 meters per second. These two examples on horizontal firing. Now, this one here, it is more about general projectile. Now, what does it mean, general projectile? It is when you have that object was fired in this way, and this is the angle here, and theta is 37, and VO is 20 meters per second. It was given, or VI, let's say I'm using VI. Okay, and the first thing that we have to start with, even if they did not ask, is what is VIX and what is VIY? VIX, it is that 20 meters per second times cosine 37, and that is, you're gonna calculate first what is the cosine 37 times 20, and that is gonna be 15. Yeah, keep it here. You don't have to stick with, oh no, for this one you have to round it for the answer, but when you're gonna use it, it's much better to use it without the rounding. And here 37 times, like sine that angle, times 20 is going to be your, okay, then this is 20 times sine 37, and that is going to give you 12.04 meters per second. Then this is part A. Now part B, let me, okay, bring it with us. I need to have more space here. Okay, then what is the maximum height it achieves? Now, something that you need to know always when we are going to ask about the maximum height, that this quantity is known. Let me list for you the quantities. Remember, each equation is 4 variables. When it's gonna say maximum height, then we know that Vy, V at that velocity is 0. And we know that Viy is 12.04. Here, by the way, okay, you should have it 12.0 for the sake of significant figures for the answer. But I mean, whenever you are going to use it, it's much better if you are going to use it without rounding. A meters per second square is negative 9.8. and have it, okay, let's say 3 digits, and we are looking for y final. Now the best equation here is vy squared equals viy squared plus 2ay minus y final minus y initial. This is 0 here, and this one is 0 squared. This one is 12.04, and this is 2 times negative 9.8 times y final. From that, we can calculate y final to be like square the 12.04 times 12.04, okay, divided by 2 divided by 9.8 is gonna be 7.396, then is gonna be 40 meters. Then this is the second part. Now the third one, how, okay, then I'm gonna copy that here. How long does it take the ball to return to the ground? Again, here we are asking about the y, because remember the time is the one can be calculated using the y. Again, I will say I will have my quantities here to know what is really okay. Now the first thing is I have VIY 1204. I know that A is negative 9.8. I know that here, what else? When it's gonna reach the ground, the vertical displacement is gonna be 0, the y final, because it will come back to the where it was sent. And then finally here t in seconds is the one that I'm looking for. Okay, now what we can do here is we can say y final minus y initial should equals VIYT plus 1/2 AYT squared. This one here is 0, and that one is 0 as well. Then I will say 0 equal 12.04 plus 1/2 negative 9.8 times t squared. Now you can make this equation 4.9, bring it to the other side, have that t squared equals 12.04 times t, and I can drop the t's here. Then my t is going to be 12.04 divided by 4.9. Seconds, of course. Then this is the time for the total trip. Now, what is the total distance traveled Okay, here, let me, okay, take a screenshot of this question. What is the total distance it traveled in the x direction? Of course, here, this is the easiest question. It's gonna be x final equals x initial plus vx times t, and that xi is 0. And that one is, it was 15.96, I believe, 97, times the total time, and that is going to give us 39.2 meters. I'm taking screenshot of these two questions because they are really easy to answer. They don't need a solution. I expect you, of course, to go over the ones that you have in your textbook so that you will have plenty of practice. And also, I will leave this for you to solve. But just for this one here, what is the velocity vector at the maximum height? Of course, when we are at the maximum height, the velocity, the Vy is going to be 0, but the Vx is gonna stay the 16 meters per second. Okay, now what if they're gonna ask about the velocity when it reaches here? You need to find the Vy by itself, you know Vx, and then you will be able to solve using the Pythagorean, find what is that velocity and also its direction. Another thing that they asking about in F, it is what is the acceleration vector at the maximum height? Of course, it is AY equals negative 9.8. Some of the students, they're gonna think that it's gonna be negative 0, and that is not true. I hope that this is gonna give you more understanding for that motion, and I will continue posting more videos for chapter 3. Thank you. Have a great day.